All right, part 2, the backside, the homework section of Integrated Math 2's Practice 3. First 6, I've asked you to multiply these various polynomials, and then for the last 6, I've asked you to factor them. So let's go through each one. Number 1, we'd have to distribute -5 into the parentheses. -5 times 2x is -10x, and -5 times a +3 is a -15. Number 2 is two binomials, so I have to start with x times x, which is x squared, x times -5, which is -5x, 7 times x, which is +7x, and 7 times -5, which is -35. The two terms in the middle are like terms. You combine them, you'll get a +2x, so x squared plus 2x minus 35. Number 3, I got to distribute 2mn into this parentheses. So the 2mn multiplies 3m. 2 times 3 would be 6. This m and this m would make m squared. This n comes in here and sees no other n's in the first term, so it just stays n behind it. 2mn times the positive n would be a +2. This m shows up, sees no other m's, stays what it is. But this n and this n together make n squared, like so. Binomials in number 4, y times y, y squared. Y times -4, -4y. -4 times y is another -4y. And -4 times -4 is +16. Two terms in the middle are like terms. Combine them, you will get a -8y. At the end there. Distributive property again for 5. When 3a to the third multiplies 2a to the fifth, 3 times 2 is 6, a to the third and a to the fifth is a to the 8th when you add them up. 3 times a +6, +18, a to the third and a to the third add up to a to the 6th power. 3a to the third times a -9, 3 times -9 is -27, a to the third shows up, finds no other a's in that term, so just stays a to the 3rd power. Binomials again for 6, x times y. Notice this is not the same letter this time as it had been previously. Y and y made y squared, or x and x made x squared. This is x and y, so since they're different letters, you got to write them both. You just call it xy. X times 1 is 1x, or just x. 1 times y is 1y, or just y. And 1 times 1 is 1. Notice that this situation, you did not end up with like terms in the middle like you normally do. That's okay, it happens. So we just box it up right there. There's our answer. Next part, we need to factor. We need to do the reverse of multiplying. So, factor the polynomials. We're going to start with this, 5x minus 20. I look at 5 and 20 and I think, okay, the GCF, or the greatest common factor, is 5. I open up parentheses and I ask myself, what would have to go inside this parentheses so that when 5 multiplies, it'll turn into 5x minus 20? Well, I definitely need this first term to be an x, so that 5 times x will make 5x. I need the second term to be a -4. 5 times -4 is -20. I have a quadratic trinomial in number 8, so I need 2 parentheses. M squared would be m and m. Two numbers that multiply to make 36 and can give me a 13. That would be 4 times 9. 4 times 9 is 36, and 4 plus 9 is 13. Since it's a positive 13, I need both of them to be positive, because +4 and +9 make +13. Another quadratic trinomial in 9, 2 parentheses, x and x to make x squared. Two numbers that multiply to make 20 and somehow give me a 9. That would be 4 and 5. 4 times 5 is 20. It's a -9 in the middle, so I need this to be -4 and -5 in order to become -9x. In number 10, got some variable combinations. I'm going to think of the GCF, and when I look at 5, 3, and 6, The biggest number that can divide all those is actually just the number 1. That happens sometimes. You don't have to write the number 1. You can, but we're just going to leave that be for the moment. They also have common letters. They all have an x, and the smallest x is x to the first. So I'm going to write it down. They all have a y, and the smallest y is y to the first. So I'll write it down, and then I'm going to open up my parentheses. xy would have to multiply some things in here and turn back into this expression. So what would those things be? Well, I definitely need the 5 in the first one, and this x becomes x squared, so I need an extra x. This y stays y, so we're good. xy times what would make a positive 3xy squared? I need the positive 3. I don't need any more x's, but I do need one more y, so that y can become y squared. xy times what would be positive 6xy? I need a positive 6. Got enough x's, got enough y's, so I'm done. 11 is interesting because this is actually a quadratic, except instead of being a trinomial with 3 terms, it only has 2. And the reason that is, this is called the difference of squares, is because the middle term happens to be 0. There's nothing in the middle. 0 b's there. So I'm going to draw my 2 parentheses. I have b and b to make b squared, and I'm looking for 2 numbers that would multiply to make a 100, but combine to make nothing in the middle, which means when they subtract, I would get 0. And the only way that's possible is it has to be the same number. Well, it just so happens that 10 times 10 is 100. In order for it to become 0, though, one of those 10s has to be positive and one would have to be negative. They would have to be opposites. So b plus 10, b minus 10. Finally, in number 12, 2, 2, and 1. For the coefficients, the GCF would be 1. I'm not going to write that, but I do know they all have an x, so I'm going to write that one to the outside. Open up my parentheses. X times what would be 2x to the third? I would need a 2x squared. X times what would be a 2x squared? I need a 2x. And x times what would just be x? Just a positive 1, because anything times 1 is itself. So there you have it. Hope that helps. Again, watch this video as much as you need to. Ask more questions in class, and I'll see you guys next time.